After completing this section, you should be able to achieve the objectives shown on this slide. By demonstrating competence in spanning tree enhancements, you should be able to identify the additional loop prevention methods available in FortiSwitch that can operate in conjunction with MSTP to deliver a more robust loop prevention solution. Loop protection enables you to prevent loops that are caused by the transitioning to the forwarding state of blocked ports that connect to network segments where a loop may still be present. After STP converges, only designated ports forward BPDUs down the spanning tree. Only non-designated ports, root and blocked ports, process incoming BPDUs. If a blocked port stops receiving BPDUs for a period longer than the max age time, 20 seconds by default, the port transitions to the forwarding state. Note that in the case of RSTP and MSTP, the age time is 3 times the hello time, 6 seconds if using the default hello time, and the blocked port is classified as an alternate or backup port. Now, suppose there is a unidirectional link failure that affects the BPDUs sent by a designated port to a blocked port. The opposite direction of the link, however, still works. After the blocked port transitions to the forwarding state, the port starts forwarding traffic in the working direction, which results in a broadcast storm due to the presence of a loop in that direction. The example on this slide shows 2 switches interconnected through 2 links. The link on the right is the alternate link, and therefore is blocked by STP. If there is a unidirectional failure on the alternate link that affects downstream BPDUs, the blocked port on the alternate link eventually transitions to the forwarding state. As a result, broadcasts sent by the PC will loop in the network. When you enable loop protection on a port, a blocked port is forced to remain in the blocking state, even if the port stops receiving BPDUs. The port does not transition to the forwarding state, nor does it forward user traffic. Note that loop protection is different than loopguard. They both prevent loops, but they use different methods. You will learn more about loopguard in this lesson. Loop protection is a per port setting, and it's disabled by default. This slide shows how to enable the setting on the FortiSwitch CLI. If you want to use loop protection, it is recommended that you enable the feature on all root, alternate, and backup ports. Enabling loop protection on root ports is important because of all the different topologies that MSTP can calculate when there are multiple instances. For example, for one instance, a port can be a root port, but for another instance, it can be an alternate or backup port. When enabled, loop protection is applied on the alternate or backup port on a per-instance basis. When you enable rootguard on a port, the port ignores superior BPDUs. The goal is to prevent a given port from becoming the root port, which would result in a topology change and possible service disruption, because the traffic could be rerouted through a suboptimal link. In addition, rootguard can protect the network from attacks from compromised endpoints that are used to capture traffic and steal information by generating rogue BPDUs. Rootguard is a per port setting, and it's disabled by default. This slide shows how you enable the setting on the FortiGate GUI and CLI. It is recommended that you enable rootguard on a port that connects to a switch that should never become the best path to the root. For ports where you expect to connect only endpoints, it's often better to enable BPDU guard, which you will also learn about in this lesson. When you enable BPDU guard on a port, the port is shut down for the time configured in the STP BPDU guard timeout setting, 5 minutes by default, when the port receives any BPDUs. After the BPDU guard timeout is reached, the port is brought back up, but will be shut down again if more BPDUs are received. BPDU guard is a per port setting, and it's disabled by default. This slide shows how you enable the setting on the FortiGate GUI and CLI, and how you change the BPDU guard timeout on the FortiGate CLI. You can also reset the status of ports that are brought down by BPDU guard by running the FortiOS execute command, shown on this slide. Most of the time, it is recommended that you enable BPDU guard on a port that connects to an endpoint. Endpoints are not expected to send BPDUs. If they do, it could be an indication of compromise. You can run the command shown on this slide to display the BPDU guard status for all ports on a managed switch. The example shown on this slide indicates that BPDU guard is enabled and triggered on port 2. The output also shows the timestamp of the last triggered event, the total number of triggered events, as well as the configured timeout. Loop guard is another loop prevention feature. However, unlike loop protection, root guard, and BPDU guard, loop guard does not rely on BPDUs and the port state. Instead, loop guard works by periodically broadcasting loop guard frames on the native VLAN of a port. A loop is detected when the same loop guard frame is received on the sender switch, which is followed by 40 switch shutting down the port for the time specified in the loop guard timeout setting, 45 minutes by default. The original loop guard implementation did not prevent loops on VLANs, other than the native VLAN. For this reason, the loop guard feature was improved to include the MAC move option, which instructs the switch to also monitor for repeated MAC address flapping events, which are likely caused by a loop. To enable MAC move, you define a MAC move threshold other than 0. The threshold refers to the minimum number of MAC addresses that must flap between ports within a second. If the threshold is reached for 6 consecutive seconds, loop guard is triggered and the port is shut down. This slide shows port 1 and port 2 on 40 switch connected to a switched network. Both ports are assigned VLAN 10 as their native VLAN, and allow VLAN 20 and VLAN 30. Because loop guard is enabled on port 1, 40 switch broadcasts loop guard frames on VLAN 10 on that port. 40 switch then shuts down port 1 if it receives a loop guard frame sourced from port 1 on either port 1 or port 2. If you also want to detect loops on VLAN 20 and VLAN 30, you must enable MAC move on port 1. Both loop guard and loop protection detect loops in your network. However, because loop guard does not rely on STP, it can detect more loop cases than loop protection. For example, if you disconnect the uplink on port 2 in the topology, loop guard will still detect the loop on port 1, but loop protection will not. Note that loop guard is designed to work with STP, not replace it. Loop guard is a per port setting, and it's disabled by default. This slide shows how you enable the setting on the FortiGate GUI and CLI. If you want to enable MAC move, you must configure the setting directly on FortiSwitch. Note that the lower you set the MAC move threshold, the higher the chances are of you getting false positive for loops. The administrator can also reset the status of ports that are brought down by loop guard by running the FortiOS execute command shown on this slide. You can run the command shown on this slide to display the loop guard status for all ports on a managed switch. The example shown on this slide indicates that loop guard is enabled and triggered on port 1. The output also shows the timestamp of the last trigger event, the total number of triggered events, as well as the configured timeout. A value of 0 in the MAC move column indicates that the MAC move feature is not enabled. RPVST Plus is a Cisco proprietary protocol that calculates a separate RSTP topology for every VLAN created on the switch. RPVST Plus does this by sending separate BPDUs for each VLAN. Each BPDU is tagged with the VLAN ID they correspond to. MSTP can also calculate a separate RSTP topology for every VLAN in the region, except the information for all instances is included in the BPDUs sent from instance 0. In other words, MSTP can offer the same as RPVST Plus, but with much less overhead. FortiSwitch can interoperate with RPVST Plus switches. To achieve this, FortiSwitch pretends to be an RPVST Plus switch at the boundary ports that connect the FortiSwitch MSTP region to the adjacent RPVST Plus switch. RPVST Plus interoperation works as follows. There is no support for a different route bridge for every VLAN. The administrator must adjust the bridge priority setting on the switches to ensure that the route bridge is the same switch for all VLANs. The root bridge can be in the MSTP region or in the RPVST plus domain, but it must be the same for all VLANs on both switches. If 40 switch detects that the root bridge is different on multiple instances, the port is flagged as inconsistent. 40 switch simulates an RPVST plus switch by replicating the BPDUs on instance 0 for every VLAN ID allowed in the port. 40 switch processes BPDUs received on the native VLAN only. BPDUs from other VLANs are used only for VLAN consistency checks. VLANs on the adjacent ports must be consistent. If you allow more VLANs on a port than the 40 switch model supports, or if 40 switch receives BPDUs on a VLAN that is not allowed on the port is flagged as a VLAN mismatch. Check the 40 switch feature matrix for information on the VLAN capacity of each 40 switch model. RPVST Plus is a per port setting and is disabled by default. This slide shows how you enable the setting on the 40-gate CLI. Congratulations! You have completed this lesson. Now, you will review the objectives that you covered in this lesson. This slide shows the objectives that you covered in this lesson. By mastering the objectives covered in this lesson, you learned about the most common 40 switch deployments, and how STP and other loop prevention methods can be used to ensure a loop-free topology.